This is a panel discussion about reducing the gap between design and operation in new buildings. And the format will be about half of the session devoted to presentations by the panelists, including myself. And the other half will be devoted to discussion, as well as, if time is left, some questions, hopefully from the audience. So before starting my introductory presentation, I would like to present the panelists. First, Dr. Don Mclean, who has 40 years of experience in the development and use of building simulation software. He founded IES in 1994. IES, as most of you know, is probably the most widespread building simulation software in this region among A&E consultants. The other panelist is engineer Michel Saab, who is a mechanical engineer with more than a decade of experience in building energy efficiency. He is currently manager of sustainability at Masdar, and he is responsible for the implementation of key performance indicators for energy efficiency and demand-side management at Masdar City. As for myself, I have more than 25 years of experience, gained both in corporate and academic research. My research topic has been consistently energy efficiency in buildings and cities, but with a focus on numerical aspects such as modeling, parameter estimation, forecasting, optimization. I have been a professor since 2011, and before that I was heading the energy management department at Masdar City, where I actually collaborated with Michel for a few years. So, as I said, I will start with a brief, let's say, introduction of this topic, and then Don and Michel will each give practical examples of how to address this performance gap. So, the origin of the problem, I would say, is the fact that the goal of building energy performance modeling or calculation or estimation is to demonstrate compliance with some mandatory or voluntary prescriptions. And these prescription frameworks are usually quite standardized, understandably, so they enforce particular profiles so that, you know, certification among buildings can have a comparative value. However, there is significant evidence to suggest that buildings, once they are built and start operating, do not perform as expected, as predicted by these compliance models. And this is what is called the performance gap. Why is it a problem? Because, of course, to a certain extent, as I mentioned, it is expected that these models will not correspond exactly to the reality, because that's not exactly their purpose. But it becomes a problem for three main reasons. First, there is a lack of credibility in public view of these energy performance certifications when people see that a building certified to consume a certain amount of energy actually consumes 50% more. It is also a major source of uncertainty for national energy policy designs, because these mandatory prescriptions are the basis of these policy designs and are used for predictions and planning. So if they are not reliable, it could be a problem from the government side. And finally, if these models are not really accurate from an operational point of view, then we use this possible benefit of implementing them for optimizing the controls of the building or assessing future retrofits, which is a pity because a lot of money is spent on producing these models. So the panel will explore some of the underlying causes and also discuss possible remedies. Now, first, the magnitude of this gap. What are we talking about? There's more and more information about this. There was a study about LEED buildings and how they differ from what was predicted to what is actually happening. There is a website now, UK one, among others, that I mention here, where you see, magnitude sometimes exceeding 50% between what the compliance model predicted and how the building is actually performing. And the sources of this gap are of two main categories. One is the methodological origin for the gap. The model, as you can understand, any model of a physical process, including a building, makes some simplifications. Otherwise, you cannot, it's just the physical processes are too complex to be modeled in any great level of detail. The timing of the compliance determination is a problem because it's usually done at design stage, and it precludes all the changes that are done during the construction process. So we don't have as-built information when we are building these models, and even less as commissioned, because even during the commissioning, you change the set points, you change the schedules, etc. I would say also, this is more controversial, there's a lack of mechanism for handling or even sanctioning model actual discrepancy. Of course, the question is, do we want to sanction this type of discrepancy? The other source of the gap is the uncertainty that is inherent in the data that goes into the model. First, the building environment. The weather that is used is usually taken from airport monitoring stations. It's not the urban weather, which can differ, as we know, significantly from the rural airport weather. Then you have things like obstruction of neighboring buildings. This is usually not considered, although more and more it is, but it's usually not. You consider your building to be isolated and not obstructed, so that makes quite a difference in terms of solar gains. There are other issues there. The physical characteristics of the buildings and the technical systems, of course, are either not well known or will differ in reality. For instance, the sizing of the chiller or the equipment, etc. The designer makes some assumption, but actually when you go and buy the actual equipment, you may not find what was assumed. So you buy a different size chiller, which changes the efficiency profile, etc. But also in terms of the U value of the walls, especially the infiltration rate, the leakiness of the envelope is something extremely difficult to guess pre-construction. And of course, there are other uncertainties. The quality you assume when you're building your model and the actual quality can be very different. The use type can change. You think it's going to be residential, but it's partly office, etc. The occupant behavior, things like the set point, temperature set point that you assume in your model, And then, you know, the tenant may choose to set a different value. And of course, the operation and maintenance and fit out, very important in some instances, can differ significantly from design assumptions. Now, there's this new notion of a performance model. So I talked until now about what is common among A&E consultants, which is the compliance model. So you build your model to demonstrate compliance with certain prescriptions that are either mandatory or voluntary. But now, how do we want to move from this compliance model to what we call a performance model, which is a model that is closer to reality? And how to get there, and why do we need such a model? So first of all, to a large extent, the discrepancy between the actual and the compliance model prediction is differences in operating condition and exclusion of non-regulated loads from the model as required by the compliance framework. So theoretically, at least, this gap can be significantly reduced if the building doesn't follow the compliance prescriptions, or at least in some instances, but rather tries to get as much as possible information relating to the actual building operating conditions. So that's what we call a performance model. And so how to move from one to the other, how to fine-tune the compliance model in order to end up with a performance model that is closer to the reality of building operation is something that is partly still a research topic. That's why I'm interested in it, but also partly is being addressed in existing, the most advanced existing products, commercial products, as Don will explain, and is being addressed in other ways, as Michel will also explain for Masdar City. Now, again, one way of transitioning from compliance model to a performance model is what we call calibration. This is, basically taking actual operational data, usage data, energy usage data, typically utility bills, and trying to tune your model so that the predictions of your model correspond to the utility bills. So you need at least 1 year of operational data, 1 year of utility bills, preferably more, to do this. And sometimes it's done manually. You just tweak the parameters. More and more it's done automatically. That's the research part, but also some commercial software are starting to do that using evolutionary algorithms. We'll not get into that. Another approach is online self-tuning. So instead of using the 1 year of utility bills, you are receiving in real time. In most modern large buildings, you have these extensive building management systems that are monitoring pretty much everything in the building, and the data is very underused typically, as Don will also explain. So we can use this data to build a more reduced model of the building in different ways, and then this model can be used for predictive control of some systems, or even fault detection and diagnosis, and other applications. Here I illustrate a case of model predictive control for those of you who have heard of it, but it's really not relevant to this discussion, just to show some applications of online safe tuning of the model in order to transition again from the compliance model to a performance model. Some discussion points. So we saw that the performance gap is not entirely unexpected given the nature of the existing compliance frameworks everywhere in the world, but we saw it's becoming a problem from a credibility point of view and other viewpoints. And of course, this gap that is mainly due to the nature of the compliance framework can be aggravated by things like inaccurate data, shortcomings in the methodology, calculation methodology, bad modeling practice, unfortunately, exists sometimes, and last-minute changes that are not well documented, commissioning that is either not conducted properly or not documented properly, complacent operators, again, that exist, who just want to follow the easiest path, basically. Insufficient maintenance, which means the system that you modeled is now operating at 75% of its efficiency after 1 year only. And unpredictable occupant behavior, not much to be done about that. And how to address these different sources of performance gap. I list a few questions, but maybe we will go through them in the discussion section of this session. Just to introduce the next presentations, I would like to say that one way of doing that is using, and I already mentioned it before, using real-time operational data to fine-tune the model. The other way is to do it a little bit more offline by inspecting the post-occupancy performance of the building, and that's something Michel is going to talk. The first one is Don's topic, and the second one is Michel's topic, and then we have other questions that we will discuss after their presentation. So first, I'd like to ask Don to come here and present his.
Thank you, Afshin. As some of you might not be familiar with the Scottish accent, I will try and speak slowly, okay, to give you a chance to catch up from that perspective. In talking about a lot of this as a role for BIM, many of you have heard about building information modelling. It is something with which many countries are trying to bring it into the culture of construction. There's still a long way to go to make it the kind of tool that it could be. But in a similar way, the role of building simulation in the energy model is going to change over the next decade or so. So the two of these tools are going to become absolutely, or two of these models are going to become absolutely essential for how we design and manage buildings in the future. There's a big list here of different types of model. Afshin actually talked about a few of them, things like compliance models and operational models and all that type of thing. Kind of classed about 8 different types there, and they occur and are used throughout the life cycle of the building. So the first 2 or 3, concept model, very early stage, looking at what's happening. You then do a compliance model, but one of the things that we don't really do very much is a design model. And where the design model is, what you're really trying to do is you're trying to get the best representation of how the building will actually perform. The compliance model doesn't do that, and that's where the performance gap starts to come in. I'll explain that a little bit more in a second. Also, you've got things like models to help you do the commissioning. The model can then be evolved to be an operational model, and that's your best guess of how the building is performing without any other data associated with it. The calibrated model is when you would then try and take that model and try and see if it passes statistically an accurate value compared to how the building is actually performing. You've got a continuous commissioning model that once you've calibrated that model, you can then start to look at how and making sure it's performing continuously. And then the thing that everyone is really trying to get to create is an intelligent controller model. So that model will actually control the building for you. It would tell the BMS system what to do. Now, a couple of the things that are a problem in the industry, and these will help eventually, but can't help it in these issues, is that the first one is that we were involved in a project recently in the UK. It was a new museum, highly prestigious museum, and the museum was consuming 7 times more energy than the compliance model was saying. 7 times more energy, okay? So we were asked to investigate what the problem was. One of the problems was the people building the model, and for compliance purposes, didn't build a very good model, and that had part to do with it. But when we looked at what was happening, what we found is that one of the exhibits in the museum was consuming 10% of all of the energy that was being used in the museum. Okay? And the designer hadn't asked about what kind of exhibits were going to be there and what their consumption was, and the owner of the building didn't think to tell the design team, do you realise these big energy consuming exhibits? Okay? So this goes into the importance of data and what data means. And one of the problems that we have in trying to get data from existing buildings is that a lot of people might have a BMS system, but they don't record it, right? So they might record it for a day and then stop it, so it just repeats every day. The information that's measured tends to be not very good at times. It's maybe not the right thing to record. So there's lots of issues. And what is kind of strange about the construction industry is there's so many other parts that we all know about that people want data. They want masses of data. They want to take as much data as they can and process it to understand what's going on. In the construction industry, trying to get any sort of data is really, really difficult. And that sort of compounds the problem. But where you can get data, you can start to do things with it. So here's a very simple example. The little green line you see there is what the government has said is what you used to allow as a profile for energy consumption in a supermarket for food preparation. Okay? Now, in this particular supermarket, the red line is what was actually done. There was a bakery there. So in the early morning, people were coming in and they were using the ovens to heat up, to bake the bread for customers to come in the morning. So you can see that the red profile is significantly different from what people would be using in compliance. And that's where you start to get the performance gap, how the building is actually performing compared to what it's what the kind of the rules are you should use for compliance purposes. And this is the sort of thing that we see in virtually every project, that kind of way. But if we can take that red line and put it into the model as a substitute for the green line, then we can make the model more accurate to how the actual building is performing. So that is one of the tasks. How can we get the BMS data and actually feed it into the model so that the model, which is like a virtual BMS, is getting real BMS information into it to make it more accurate. This is an example. The left-hand side is the statistical averages for 3 different levels of model. The first level at the top there, where you see the 2 lines, is that's showing what would happen if you're using the compliance model. And the compliance model is the green. When you see the graph, that's the green graph, okay? The actual energy consumption is the red graph that you see below it, okay? Now, what we've done is from that top statistical line in the top left, the next one down is where we've tried to look at how we could create a better operational model, looking at the building, auditing it, and trying to see where we can make the information more accurate. The third level down there, which you see is very, very small compared to the other 2, is where we've actually brought the BMS information from the building into the model, so the model has that data in it. And when we do that, the green line, the blue line, which is just very similar to the red line, is what was actually created by the model. So the model now is simulating almost exactly what the building is doing. Okay? So that changes the complexity, that changes the kind of things that we can do. Because if you then wanted to say, how could I improve this building? The question is, would you prefer to make those assumptions and make those decisions based on the green line, which is much higher than it actually is, or the blue line, which is very closely matched? So this ability to start to get this level of accuracy is very important in how we start to address things like the performance gap. And finally, just to kind of state that once you kind of create that, we're looking at the total energy figure earlier on, it means that other parts of the model are equally as accurate, which means it gives you confidence that the deeper you go into the model, the more that you try to look at how to improve the building, you have the information and the tool by your side that actually helps you do that. Okay? Thank you very much.
Hello, everyone, and thank you for coming. Thank you, Dr. Afshin and Dr. Dawn, for the interesting presentations. So as a continuation for what was spoken, I would like to speak more about the operation side, which is causing a good, an interesting performance gap. So here is a diagram which shows you why the performance gap is happening, and this was discussed initially. So my focus will be on the most interesting side, which is on the operation side, where more than 120% performance gap could occur with bad operation and maintenance. And I'm going to talk about some of the experience we gained in Masdar City and in different energy audits, which we made for different government entities in UAE. So the main causes of the performance gap during operation are illustrated here. And we can talk about them all. I'll just go briefly because we don't have too much time. But first, we noticed a lot of, in many occasions where we did energy audits, that variable speed drives are being overridden. In design, we do design variable frequency drives for most of the chilled water systems or the air systems, and we design them for saving energy. But in reality, many of these systems are not being utilized properly. So operators may override them probably because somebody in the higher floor of the building is feeling hot. So as a simple remedy, they would just ramp up the fans or the pumps, and therefore consuming much more energy than what the design wanted to be consumed. Oversupply of outside air, probably someone is called operator and said, there is a smell in my office, could you please help me? And the operator could, as an easy solution again, ramp up the fan speed of the outside air, and therefore consume much more energy on the outside air handling unit. Continuous operation of systems. Many times you have seen buildings that are only occupied for 7 hours a day or 8 hours a day, but they are operated 24 hours a day, and even in the weekends. So all this is creating additional consumption, and therefore the gap is being increased. Poor fit-out works. Sometimes you have buildings that are lead for shell and core. So at a once the building is delivered and the certification is given, the building will be fitted out by someone who may not have any interest in lead. So then you have a poor fit-out work, and if you don't have proper control, the fit-out will not be done properly, and therefore the gap will be also increased. Lower temperature set point. Many of us like lower temperature, which is okay. But sometimes I get to see data centers or server rooms where the set point is 17 degrees. And this is seriously happening in many cases. And when I ask the IT person, why do you put the set point at 17? I don't get any document, in exchange or any proper answer. In fact, most of server rooms can live normally at 24 degrees, if not even higher. So this is a common thing I see in buildings over here. Uncalibrated sensors. Many times in any building now, especially all the new buildings, you have lots of sensors in these buildings to make them high performance. But if you don't calibrate these sensors on a periodic basis, these sensors will not give you the right information. Hence, the gap will increase. And so on and so forth. Probably I'm going to skip now because we don't have too much time. But you may take note of those because they may be happening in your buildings. Here is a screenshot I took from the BMS in Masdar City, where we once noticed that we have overconsumption on one of the fresh air handling units on the ventilation system. When we looked closely on the BMS, we noticed that if you look at the left side, the cooling valve was not closing at all. So even in the weekend, in the night, it wasn't closing. And the fan also was continuously running. So it was obvious for us that the fan is running, or the machine is running 24 hours, 7 days a week. When we did and simply changed so we tuned the time schedule of that air handling unit, you see that after we have implemented the measure, automatically the chilled water valve is closing, which is a good sign when the fan is off, and the fan is turning off in the night and in the weekend. So this was a simple thing we did and saved us. I'll show you later on how much it saved. We saved actually, since we implemented this measure on the left side, on the chilled water consumption, about 58%. And on the electrical fan energy, we saved about 51%. And that is equivalent to like almost 100,000 dirham for the whole year. So that simple measure made a big change. And I can tell you that in many buildings, ventilation systems are running 24 hours, 7 days a week. So these simple measures can save a lot of energy and money, and eventually reducing the gap. This is the Incubator Building, which is a building in Masdar city. During the first year of operation, normally you cannot really have a proper consumption because the building is still in terms of commissioning, people are coming in, so you cannot really have what you like. It cannot be optimized until at least first or second year of operation. So what we did here, once we had this stable status of the building, we did an energy audit, and we also discovered that we have saved about 30% by purely tuning the system properly and hence reducing the gap. We have, when we did this energy audit, the building was having an energy utilization index of 182 kilowatt hour per square meter per year. And after we have implemented certain measures, the building is currently at 130 kilowatt hour per square meter per year. So the gap is also reduced by implementing simple measures. Here is what we do in Masdar. We are always monitoring the consumption of our buildings, of all the buildings we have. And because of that, we are able to always fix any issues we might have. Because you may think that Masdar city shouldn't have problems. We have the best buildings. And yes, we do have very good buildings. But per experience, if you don't keep an eye on these buildings, your consumption will definitely increase. And this is what we have experienced, and this is what we are working on. So these dashboards will show us if the buildings are reducing energy year on year or if not. So we would like to see always this arrow green, it means that we are saving energy. And you can see on the landlord area where we have the most capacity, we are saving a lot of energy because this is in our hands. But on the tenant areas, we do human behavior training. Sometimes we visit them, we tell them what is the best operation of their office space. But we don't succeed all the time. But as you see here, we have been successful by a few percentage, which is for us a good sign. So how to reduce the gap? In our experiences, we need to perform regular energy audits. We don't stop doing it, in fact. I mean, myself, I have to walk in the buildings like every day. I do this because I know that every time I walk, I'll find something where we can save energy. And by doing that, you are making sure that the buildings are properly calibrated, properly operated, and the gap eventually is going to be reduced. From the audit, you will adjust the energy systems based on your findings. You might want to change the set point or the schedules or so on. We train our building operators. We don't expect operators to come trained already because most of the operators have been working in classic building, not in high-performance building. So we need to give them this additional training to let them understand how to operate our buildings. We track the performance. This is how we can control it. And we calibrate the sensors all the time. In fact, this is a regular thing we do. And we always find faulty sensors. I don't expect any day that our operators will tell me all your sensors are running perfectly, because this is really impossible. It's too good to be true. We try to control our fit-outs. We do have tenants who come here, who come to Masdar to fit out their office space. So if we don't have the proper control on what they bring in, what material, what systems, we know that the gap will be increasing. So we make sure that we control the fit-outs whenever possible. And we share the results whenever we can. If we do good, we tell our tenants, we tell our occupants. And if we do bad, we still tell them to see how we can improve. That's it from my side. If you have any questions, we will be answering them in a bit. Thank you.
Go ahead. There's a question in the audience.
Thank you. Hello?
It's working.
Hello?
It's working. You have to put your headset.
Sorry. Yes, thank you for your presentation. Is it possible to get it? Can you send it to us?
To who exactly? I have to see with the conference organizers if usually they put them online after a few weeks.
Okay. Okay, like to learn more about this because I'm also a shareholder in a company named Beat, where we do a new technology to operate buildings automatically, like a driverless car. And 3 months ago, we get an Emirates Energy Award here. And I like to present you, of course, all of you, this technology.
Sure.
So hope to be in touch with you.
Okay.
Thank you.
All right. There's another one. We will switch between audience questions and our own discussion points here.
Prof, I appreciate very much of your inputs. The question is that I notice in the Middle East, for example, not just in Abu Dhabi or UAE, the question is that the benchmarking for hallmark is rather lower than expectation because you're going for efficiency, yet no proficiency ever in mind. So the end in mind is not there. And the question is, for example, that you find that the question of still on the optimization dimension rather than the ultimization expectation. So managing expectation seems to be the problem here because from the earlier session, I noticed that the fundamental issues are not addressed. You have to have your system designed first before design thinking. No matter how much you will try to achieve by design thinking, when the system design isn't there, you're not going to get anywhere. You can't get value without virtue. And the virtue doesn't exist in the mind of the Western way of, a journey. So I think that will you be able to go into the next paradigm shift, looking for tier one kind of expectation, the hallmark, situation rather than just a simple quadrant that you set yourself, which I think that those are low-hanging fruits. But it's not making any way. It's not a kind of original innovation, replication, duplication, renovation, all kind of those are substitute of real innovation. Can we expect something that is really not, you expect the kind of miracle, but the question is that it have to be what is the kind of expectation in management supposed to be? Thanks a lot.
Thank you. I'd like to point out that we're not, the topic here is not energy efficiency per se, but the gap that is observed between modeling and practice. But any of the panelists would like to contribute here?
No.
We have little time. I'd like to perhaps, I don't want to exclude more questions from the audience, but I had a few points I would like the panelists to address, if possible. First, given the daunting underlying reasons that we saw that explain the performance gap, is it realistic to expect that we can solve this gap, and if yes, at what cost? Who would like to answer?
Yeah, I can just tell you from our experience in Masdar, I think we can definitely minimize the gap. This is something we can do, and we have done it. But to eliminate the gap from the design stage is something very difficult to do, because how can you predict what will happen in the building during operation? So these are unknown during design stage. Unless you do a calibrated model after, post-occupancy, I don't think you can have no gap.
I think one of the problems here is the fact that when people are using an approach that's been put together to kind of do compliance, I think they have an expectation. But I think it's letting people understand that a compliance approach is a way of comparing like for like. And buildings are extremely complex machines from that perspective. And I think that trying to create that bridge of expectation from somebody saying, I've got a B-rated building, and it's not performing like that. You need to understand that there's a whole bunch of other issues. But I think the thing is that there is research that's going on at this moment in time that is going to try to alleviate that problem as much as possible, so that we'll have no gap. And I think certainly there are buildings, like say for example, the example I showed with a supermarket, where instead of using the compliance information, if somebody could actually use what that, say for example, that bakery was actually using, then in that way, that sort of thing could reduce the gap at the design stage. So I think there's a range of things that could be done to make this process much better.
Another question I had was the question of BIM. It was mentioned as disrupting technology in the previous panel. So how can BIM help solve this gap in your opinion? Maybe Don first.
BIM is potentially a tremendous solution, but we've been talking about BIM now for about a decade and a half at least, and it is again buildings are extremely complex because of the variety, and BIM systems have trying to gather all that data and make it useful and freely available for people, and use that model for a whole range of other things. Is the right thing to do. We must try and do this. It is the sensible and effective thing to do, but it's just still going to take a bit more time. But I think the thing is, it's about data. BIM is about data, but it's trying to get the data in the right form to suit the different applications. And a major application is on the energy side and the sustainability side, and that's where BIM falls down a little bit. So there's still a lot of work to get done, but it is the best future solution to some of these problems.
The other question, just to follow up on what you said, and also what you mentioned in your presentation, the abundance of data in modern buildings that are generated by the building management system. How can this data be mined to reduce the performance gap practically?
I think this leads on to something that Michel said. I think that the BMS can't record everything. It doesn't record everything, so there is gaps in what that records. But I think the other thing as well is the fact that you get sensors that will drift away and so on and so forth. So to actually maintain your BMS, to make sure you're getting high quality data from it, takes a lot of time and a lot of effort. And then to record that data, all of that is a big overhead, and the organisation with the building has got to be prepared to do that. But with the likes of doing something like that, if you can get and make savings on your building by making your building more efficient, making it better environment for people to work in, so they don't get ill as often and things like that, so you get productivity gains in that. There's a whole range of different ways that you can fund the extra effort that you need to put in to make your BMS effective, and then to have that data that you could actually make your model effective. So again, that's something I think we'll see in the future, that we'll see big improvements will make that possible.
Another, I think, crucial question here that many people are thinking of is, should we actually include a post-occupancy or perhaps post-commissioning stage in the compliance program, so as to solve this problem at the compliance stage? And if we do, then do we still need a pre-build compliance stage, or just
I believe that a post-occupancy modeling will help definitely, because many things have changed even during construction. As you know, especially we were talking about the speed of construction in this part of the world. So things could happen very quickly, and once you pay an energy modeler to do a modeling, he might be paid for doing 2 rounds of modeling, for example. So maybe the 3rd round is not paid, and this is where the changes happen. So for example, for this reason, I think that a post-occupancy modeling will help, and it will make sure that the gap is reduced, at least the moment the building is delivered, or the moment the building starts to be occupied. And this will help, as you mentioned before, Dr. Afshin, about how the government can actually predict consumption of buildings in the future. Because now, if you don't have this, there is a big gap between what the government probably predicts and what the reality is.
anything? No? So the last question I had was that the performance gap, as it is usually defined, relates to new building. But how about existing buildings? How can we make them perform better?
Well, as we explained in Masdar, we have learned that we can do a lot in doing energy audits, starting with an energy audit and then moving into monitoring of buildings. We have done it in Masdar and in different other buildings, and we were able to achieve at least 20% savings by doing tuning of the building management system. And you can do even further, definitely, if you can invest more money in the systems. And technology is moving quickly, and so I'm pretty sure any building will have a good potential of saving energy. And this is why currently you have lots of movement into ESCOs and into energy efficiency, lots of new policies related to energy efficiency in existing buildings. So there is a big potential, and it's not too difficult to save energy in existing buildings. It just needs, first of all, doing energy audits, which will cost very little, and then everything can move on from there.
I think one of the things that we're seeing globally is the fact that, particularly in smart cities, you can stick a sensor onto anything and it becomes smart. And I think we can do that in buildings. The sensor technology is getting better, and it's also getting a lot cheaper. So it means that you can put sensors through a building and get the information you require, to then use that to be fed in real time into the models. You could actually get sort of live control from the building from that. But this kind of idea of having more sensors that help you gather the information, that help you make better decisions, I think that's the sort of thing that can really start to improve the way that we can make buildings operate. And as a consequence, having for existing buildings some post-occupancy compliance, I think would be also a useful exercise to try and make all of our building stock much more energy efficient.
Perhaps we have time for one more question from the audience, or no?
There's one at the back.
No? Okay,
No,
sorry about that. Well, we can discuss after
No,
during the break.
It's up there.
I know, but she tells me we don't
No,
have
all right,
time.
sorry.
Sorry about that. Okay, well, thanks a lot for your attention, and we are available to discuss at the break. Thank you.